It's in that pathway. I got that ARRL in that app. It's supposed to work for 40, 20, 15, and 10. I think it was Byron suggested we should go ahead and try 12 and 17. You might be surprised. Sure enough, they're both with no tuner. They're both less than 2 to 1. 12 and 17. So, and I use a G90 radio, so it tunes them with no problem at all. So,
yeah, the end-fed, you should have less than 2 to 1 on all of them.
yeah. So I think it was either Tuesday evening or Wednesday evening. I put it on 17 and was just spinning through the frequency, and it's not very wide. It's a very narrow band. But I heard a guy talking, so I ended up talking to a guy for 10 minutes in Phoenix, Arizona, on 20 watts, and a 66-foot wire. So he was running 500 watts on some type of directional antenna. So
Dave Kassler did a evaluation of that ARL antenna, and then he did an experiment. Did you see the one where he extended it? He added another 60 feet and got it to work on 80, and had everything. Okay. We're going to talk about analog integrated circuits. There's the high-speed ones that are designed for doing VHF and UHF called, what is it called? No, I forgot. It's not multi-mode. Anyway, and then talk about IC packages. Monolithic microwave integrated circuits. And they're specifically designed, like I said, for doing VHF and UHF. They're made with a 50 ohm input output impedance so that you can connect them with transmission lines, which you do on the circuit board by actually using what they call microstrip to make the connections between them. They have a very low noise figure, usually less than 2 dB. They're normally amplifiers, but there's some other functions that are in an MMIC. And like I said, it's basically what's used if you're doing any kind of VHF through microwave. So what characteristic makes it a popular choice for VHF and microwave?
I like the nearly infinite gain selection.
Like that, yeah. And 100% efficient. No heat.
So which of the following noise figures is typical of a low noise UHF preamplifier?
Okay.
Less than 2 dB. What's the most common input output impedance of an MMIC?
Okay.
They're normally made from, well, most of your integrated circuits are based on a silicon substrate. In the case of MMICs, they use gallium nitride or gallium arsenide because they operate at much higher frequencies. In the case of gallium arsenide, they have higher electron mobility, which helps in some cases, but I can't explain exactly why.
Because it's a higher frequency, you want a rapid.
Right, but then so does gallium nitride because that's the most commonly used one. And according to the data, it's the highest frequency. So I don't exactly understand why the electron mobility is part of gallium arsenide, why they point that out, other than the fact that it's a test question. So which of the following materials are likely to provide the highest frequency of operation?
D.
Now you brought it. Yeah.
Why is gallium arsenide useful?
D.
And that's what microstrip looks like. There's also a strip line. It's requires multi-layer circuit boards because you actually have to embed it. It's a lot easier to manufacture microstrip. And you just calculate, depending on the dielectric constant of the circuit board, the thickness and the width of the trace, and adjust that to make it a 50 ohm impedance, so it looks like a transmission line. One of the ways that you power up an MMIC is either using a series resistor, a series choke, or both of them in series with the power input, so that you isolate any harmonics or frequencies getting back into the power supply and being transferred to other circuits that are connected to the same power supply. So what type of transmission line is used to connect MMICs? How is power supply the most common type of MMIC?
A.
Okay, packaging. When integrated circuits first came about, they came in what we call dual inline or DIP dip packages. They have little either a plastic or ceramic package with rows of pins on each side of it. Anywhere from, I think the smallest ones were like 4 pins. Those were kind of rare. Most of them were 8 or 14 or 16 pins, and then they got bigger and wider. They fit into holes on the printed circuit board, so we call it a through hole type of package. And normally you would make plated through holes on the board and the pins fit through there, so you can make a connection to the pin on the top or the bottom of the board. That's a typical dip. And the one on top is what we used to call dead bug, because when you had to go do troubleshooting and fix things and you were missing an integrated circuit, you glued it upside down on the board and wired it into the circuit. So what's the characteristic of dip packaging used for integrated circuits?
D.
Right. Dual row, because it's a dual inline package. Which of the following device packages is a through hole type?
A.
This shows a lot of the more modern stuff, surface mount. And you can see the bigger chips there with the, it looks like little centipedes with those little legs that get soldered onto the top of the board, onto pads. The other components there are resistors and capacitors, and they actually have contacts on the bottom. The part of it that you see wrapping up the side is just so that you can get solder to flow underneath it, but the connection is actually directly to the board on the bottom of it.
Sure don't have a lot of room to hand solder, huh?
No, but
You can do it.
Oh, I know you can.
You
I
can-
prepared some, but
you can run a iron
I can't do
along
it.
real quick. And it'll solder all of them if it's really.
Yeah, or a heat gun. As long as you hold it, because I discovered the first time it blew away.
That's true.
Surface mounts are preferred over through-hole dips because they have much smaller leads. Here they're talking about them leadless, but most of the high-density ones, to me, have leads. They're just very short leads.
But you have to worry about the appearance on the top and the bottom of the board with the solder, you know. On those, you just.
Yeah,
worry
you
about
kind of
the-
hide it. It's underneath,
You worry about the top and that's it.
right? But basically, you have much shorter circuit board traces using those smaller packages. Printed circuit boards can be smaller because you take up less real estate for the same amount of components. You've got less parasitic inductance and capacitance because of the shorter lead length. And with longer traces, you're going to have capacitance between the traces. So the shorter those are, the less capacitance between the traces, and the less inductance, the shorter they are. So you can do higher frequencies with surface mount components. So why don't you use dip packages at UHF? You get a high enough frequency, the lead coming out of that dip package could be a quarter wavelength or some fraction of it where you're going to get a big phase shift. So which of the following packages would be most suitable above HF? Yeah, the axial and the radial are still through-hole components. Those would be capacitors and resistors and chokes normally in those kind of packages. So what advantage does surface mount offer compared to through-hole?
All of the choices are correct.
Finally got an all above. Now those on the technician, there's a lot of them. There's a few on the general. There's very few on the extra, it seems.
So I worked for what is now Collins Aerospace, was Collins Radio, Rockwell, a bunch of stuff all the time, but back in the, I don't know what it was, late eighties, early nineties, maybe, converting to surface mount. A lot of the cool we made was commercial and government avionics, so some of them are in the equipment bay on a commercial jet, for example, it's up in the nose cone somewhere. On the ground, sitting at a jetway, you can go 120 degrees in the equipment bay, and then you're up at 30,000 feet. It's not environmental control.